Let's get started. Our first speaker, keynote this morning, will be Aiaz Kazi from SAP. He's the SVP of Platform Strategy and Adoption, and his title will be Delivering the Enterprise Fabric for Big Data.
All right. Morning, everyone. All right, so a few people have had their coffee. It's great. Those who didn't say good morning, well, it's time to get some coffee. All right. Well, excited to be back here again. I had a little cameo in Jon's keynote yesterday. Thank you, Jon, for that. And thank you for having us here. It's a very exciting time for us at SAP. And we'll talk a little bit about why I'm here and why it makes sense for us to be at Spark Summit. So stay tuned. I want to spend some time on the title of the talk has a hint on what I'm going to talk about. It's the enterprise fabric for big data. And I know we all use the word big data and we use it liberally, and most of us mean very different things when we talk about it. So I wanted to spend a few moments talking about what does this mean in the enterprise, sort of set the context before we get into some of the things specifically related to SAP and Spark. So is it possible to shut that door or bring people in from there? Thank you. So in the enterprise, all data is important. And whether that's small, medium, large, big, and that's where the word big itself is a misnomer. But if you take big data conceptually to mean all of that, then it makes sense. So in the enterprise, remember, all data is important. And what are the dimensions of this data? So if you look at deep, and I'll talk about a few of these, and deep means storing data at the most granular level so that you can ask any complex question and flexibly have an answer. So maximum flexibility with the highest granularity. That's the thing to keep in mind. Broad. And when we talk about broad, the clear, and for those who are familiar with the 3 V's of that typically get touted about for big data, and we talk about variety. Broad is very similar to that. I mean, but broad is broader than typically what you would say variety. Variety is across structured, unstructured, binary blobs. Yes, all of that. But broad is also across all the aspects of your organization. So whether it is in the small INI files that are sitting on your laptop that then can be overridden by a firm-wide version and then a net-wide version, being able to manage all of that, being able to manage, or its large stores of data. So going from the small to the large across the breadth of data in the organization that's distributed. Simple. Simple means storing all the data that is at its basic unit and ideally storing it once. And the key with simple is any data that can be derived will be derived. If it's something that can be derived from 2 other pieces of data, you would derive it on the fly. And not keep a snapshot, not build aggregates, not build any of these capabilities, but you do it all on the fly. Those are the things that you have to keep in mind for what you need to deliver an enterprise data fabric. We talk about real time, and we talk about speed, and this is where the V in velocity comes in, right? And an immediate implication is high velocity, massive speeds. But really, in an enterprise, you need to address, and the enterprise big data in that sense needs to address all speeds, whether it's data at rest and data in motion, whether it's historical data that's sitting ideally in different stores, Hadoop being one of them, or it's data that's coming in, streaming in, or coming in at different speeds, and you need real-time access to some of this. So there's a common misnomer, and I've fallen prey to it as well. Sorry about that. I've fallen prey to it as well, that we tend to use real-time very loosely for all speeds. But really keep in mind, this is all speeds for the enterprise. And here's the fifth dimension, which I think is key to understand how data continues to get transformed in the organization. Interactive means I'm able to ask a question, get an answer immediately, and able to ask the next question almost instantly, so that I know what I'm trying to learn or discover from my data. And that's key, and the world of analytics is changing drastically across all these dimensions, but more so because of the interactive dimension. And if you think about it, today it is, and that's changing too. Today it is humans asking the questions, humans answering and responding. It could be humans answering the questions, machines responding, machines answering the questions, humans responding. The whole IoT, M2M discussion takes on a whole new meaning. And frameworks such as that can handle event condition action, as an example, will flourish under this sort of a capability. I don't know how many of you here are familiar with, it's actually a little startup, and it's one of my favorite tools to play with every once in a while, called IFTTT. If this, then that. It's actually a very, very simple, very easy to use framework for doing event condition action. That's an easy way to look at it. And that plays very well into all of this. So what's important through all of this? I think establishing context. Context for what does the data mean when it is presented? What does the data mean when I'm looking for answers? What is the context? I have a number. The number is 50. What does it mean? Is it the average age of the individual? Is it the speed limit? What tags are associated with my data? What's the context? And providing this context, that's where real time comes into play as well. Providing this context in real time at point of interaction has become paramount these days. Right? So how do we get there? What are the technology requirements for delivering on these capabilities and delivering such a context? So key technology requirement, and you'll see this across all the aspects of the data, but also a large portion of that influences this is also interactive, is how close the data sits to where the operations need to take place, and how much of compute are you bringing to the data. So in-memory is key in all of these as a key requirement for delivering this. This should be fun. Since it started buzzing. All right. Linear scale. As you extend your computing power, you extend the number of cores, and the massively parallel processing talks about the multi-core architectures. As you extend your number of cores, you need your performance to scale linearly, and you have to work this into your technology. You have to make sure that this can be delivered. And we all know, we know the distributed story, distributed data sets, distributed memory, distributed clusters, all of that, bringing all of that into play. So this is a key capability that any technology needs to deliver. So I just wanted to set that context before I go into, and now before I get to what we can talk about from SAP and Spark, I want to spend a few minutes. I recognize this is a new audience for SAP, and some of you might not even know of a product that we have for the past 2 years, a completely reimagined platform in memory called HANA, SAP HANA. How many of you have heard about SAP HANA? This is very gratifying. It's a good show of hands. It's fantastic. Again, it has the same basic capabilities. I've left the capabilities on for what you need to deliver with the technology. And I'm going to highlight 2 or 3 others. There's a lot more where this came from. But just to give you a flavor, how we do this is to provide columnar and row store and provide compressed data, provide compression and work on compressed data in memory. That's a key aspect of doing this. And then we talked about on the fly, no aggregates. So everything that can be derived will be derived. And any kind of views, materialization is all on the fly. So it's not that there are no aggregates, there are aggregates, but they're built on the fly. Right? And I've just highlighted a few capabilities, functional capabilities that we provide. There's a lot more. Effectively, HANA is, the capabilities here that I've highlighted are text and text analysis, geospatial, analytics, and your classic BI analytics. These are workloads that you would use HANA for predictive planning, all of these capabilities. But what HANA is at the heart, and it's a nice picture, and thank you to my lovely marketing department for taking my bullet slides and making a nice picture out of it, and still keeping it clean enough for all of you guys. It's a database management platform, an application development platform, and has a whole bunch of functional libraries and engines, capabilities that we talked about on the previous slide. You can take a look at saphana.com for more information. I did want to talk about a few things. We've about 2 years in the market since we launched this, and the numbers there speak for itself. More than 3,300 enterprise customers, over $1 billion in revenue. I think any big data player that of any metal, you add them all together, I don't think they'll be getting to that kind of revenue anytime soon. So I think keep that in mind. This is serious stuff. We know the enterprise data, and we work with that, and we are extending that out to the context and providing the real-time context for our customers. The one I'm most passionate about, and my team sits here, right here, the startup focus team. We also work with startups. A platform isn't a platform if there aren't others building on it. So we have over 1,500 startups today building on HANA, and that's a program that's also roughly about 2 years old, or a little around there. And it started out slowly, and we've built it up, and we've now got quite a few of those solutions available in the market from the startups that are running on HANA, just to keep that in mind. Over the numbers close to 120 or over that. That should give you a flavor of HANA, so that sets the stage for why am I here, right? Let's talk about HANA and Hadoop, something all of you guys are familiar with. So as we look at Hadoop, we know that Hadoop's here to stay in some shape or form, right? And the evolution of Hadoop is here to stay. We looked at Hadoop, our customers looked at Hadoop, and there's a statistic that's going around that about 55 to 60% of enterprise customers are looking at Hadoop, but about 15% of them are in production or less. So that's an impressive statistic and quite a big gap. So why is that? And I can probably relate our experience when we looked at it. It's great. We have our own, before Spark, we have our own connectors into HDFS. We work with some of the leading distributions. So why is there not as much adoption? And when you take a look at those revenue numbers I showed before, if I was to take a look at revenue numbers around Hadoop, they're minimal. One of the things we found was the capabilities we talked about, the in-memory, the linear scaling, the massively parallel processing, all of those capabilities, and the distributed. We didn't have anything working with Hadoop that provided those sort of capabilities. And that's where we came upon Spark. And when we started working with Spark, we found that Spark had the most important thing here is not specifically about what we're about to announce or is the mindset. It's a common mindset. They're doing similar things. The folks from Databricks that we've worked with, doing similar things that what we've seen in the HANA journey. They're also focused on in-memory, on driving performance, on making sure that we can take HDFS and accelerate that and make it available to customers that makes it more usable and faster. And we've been, on the HANA side, we've got performance gains from existing systems, anywhere from 50, 100, 1,000, 10,000. We even have sometimes we have performance gains greater than 10,000, more than 10,000x. Now that's saying quite a lot. In the labs when we worked with Spark, we saw, even on Hadoop, we saw 5 to 10x improvement of what Spark brings to the table. So this is fantastic, first of all. And again, it's not just about speeds and feeds, but it's about understanding. This is not about data stores. This is not about parallel data stores. This is about the engines that together can deliver an enterprise data fabric, right? Engines that are good for specific things and can deliver specific capabilities. And sure enough, there might be places where both of us do similar sort of things, and frankly, it's the customer choice at that point, being able to pick what makes sense for them depending on their skill set and depending on where they're coming from. So let's talk about what does this mean to you. And from a Spark developer or a Hadoop developer perspective, you now can bring all the applications that you're building, whether you're using GraphX, whether you're using machine learning library, whether you're using Spark SQL, and you're coming in, or streaming, and you're coming in building these applications. You can now bring these applications to corporate data, bring them to the enterprise. That's what we are good at. We take the enterprise and we extend from there. So now you can take your applications. If you're a developer or you're a startup, and this is something you're looking for, this is your ticket to bringing these applications to the enterprise, and keep your eye on the price and the revenue that you can expect from some of these things as well. So that's one aspect of it. But the other aspect of it is really understanding the in-memory genesis from both sides, and now bringing in capabilities which will allow you to then push down. And this is something that we've done from the HANA side, and it's something that we're looking to do from the Spark side as well, to push down these capabilities and use in-memory directly across the two. So you'd share the memory. And I'll talk a little about that in the use cases coming up. So for Spark developers, if you're building Scala, Java, Python, any of these applications, this allows you to now bring in, not only just access the data, but also access the engines in HANA and be able to run geospatial, be able to run predictive, be able to run. So it's different workloads that you can actually run in HANA. And that's a big thing. It brings you to the enterprise, gives you additional capabilities. And we tested this out on we have HANA 1 on Amazon, on AWS, and the test that we did in the lab was with, of course, Spark on AWS as well. So when we tested out both the bidirectional capabilities between HANA and Spark, and we tested this on Amazon, and this was worked beautifully. And what we found was customers need this capability to extend out. So for looking at it from an SAP perspective, our ability to extend the enterprise fabric for big data out into Hadoop, accelerate Hadoop and bring in data from there, but not only just bring in data, but leverage the capabilities that now Spark brings in. It brings in parallel programming languages. From the programming language perspective, it has the same mindset on SQL as we do. And most importantly, it brings in a choice for the customer. This is independent of any Hadoop distribution. And you could use your favorite Hadoop distribution that you like, or even a stock one if you want, for while you're doing development. So that's, I think, key behind this for SAP to extend this out and also bring in, you think about a customer. Customer not only has the choice, but now a customer that has HANA, typically in the landscape will have Hadoop or Spark somewhere, right? And if not Spark, Hadoop. This allows people who are Hadoop developers and familiar with Hadoop and HDFS to be able to use Spark to access what's in HANA easily without having to learn an entirely new system. Same for the people who are HANA developers or used to modeling in HANA. They can now get capabilities directly from the Spark system, whether it's the machine learning, whether it's the stream processing, which we also have. But I like the Twitter stream example yesterday in the keynote. That was fantastic, that Ali did, the demo, and using these capabilities across. So I think, again, keep in mind, enterprise going across what we would term as 100% of the data, the entire corpus of the data. And if you think of the enterprise fabric for big data. Today we are talking about HANA and Spark. If there are other capabilities and engines that need to be put in, this does not obviate the need, this does not obviate adding them to it. So if there are other specialized engines for data management, they can be added to this data fabric as well. So what are we announcing today? I know we had a little teaser yesterday. I think it's no prizes for guessing. We are announcing a certified distributor of Spark 1.0 and our partnership with Databricks. And yes, you've guessed this, but what you're looking at is the first step. The first step of things that we are looking to do further. We're talking about making sure the in-memory connects work faster, pushing down queries into both HANA and the Spark side, depending on your workloads. If you're in a transactional workload, you typically do it in HANA. If you're in an analytic workload, you take a look at what type of analytics, what type of advanced analytics you're doing. And then if it's predictive or it's text analysis or geospatial, you do that largely in HANA. Depending on your skill set, you might do graph and machine learning, etc. in Spark. If you're looking at other workloads, it's pretty straightforward which one you would pick. But having said that, I think the key really is to understand that this is the first step. We're looking at how we can take Spark and add more enterprise capabilities. The security models in HANA, as an example, are one that we hope to figure out a way to get more of that leveraged into Spark, as an example. And there's other areas of putting this together. Databricks just announced the Databricks Cloud yesterday. Like to see how we can get more of the HANA services in the Databricks Cloud and vice versa, get Databricks Cloud into HANA. Having said that, I think a key aspect of it is, and yesterday when this announcement was made, we had some fun and games. Hopefully we have got spark.saphana.com. That URL itself should tell you a lot. And go download it. If you're a developer, this is available for you today for free. If you're a startup and you're developing, we have 1,500. I'd take a look very hard if you're one of my startups to see what you can leverage from Spark. Or if you're a startup in the Hadoop system and have not looked at HANA yet, I would say take a good hard look. Don't say. So now let's spend some time on, I have 2 or 3 use cases. Maybe in the interest of time, I'll talk about one that explains this picture, give you a minute to sort of look at the picture, but largely it is how the fabric works, the connection between HANA and Spark. You'll see some bidirectional arrows there that say Smart Data Access. So what is Smart Data Access? From a HANA perspective, it is the ability to get, it's a query federation mechanism, the ability to push down queries into its native environments no matter where these engines are running, and being able to get the result sets and work with the result sets in memory. And that's key here. So if you take a look at a financial, this is somebody who's already doing this, looking at financial loan documents and trying to figure out who their best customers are and the propensity to default, but who their defaulters are, right? And now they're looking through millions and billions of records that have been transformed from paper records and have been kept in HDFS. They're bringing back a reduced set, right? And this will explain the complementarity of the two technologies as well. They're bringing back a reduced set of possible defaulters in the larger set of across all history, possible defaulters, and then also bringing back the best customers. Now I'm bringing that back in. Again, key here is this is then stored, and I'll get a little under the covers here. This is then stored as a table, comes through RDD into a table in Spark in memory, and is stored on the Spark side. It's in memory, it's a table in memory on the Spark side. We just reference it. We don't pull the data across. through the smart data access mechanism, you're now able to analyze just as if that table was sitting in HANA. Right? And you're sitting across, and that could be multiple other sources that HANA is accessing as well, but along with the data in HANA. And that's key to recognize here. And so let's say we bring the data, we do some analysis across this, and we find the propensity of the people to default in the next month or in the next 6 months. Now we find that while we're doing this, it also generated some junk data. We want the system to learn how to filter out this data. Now I can go back and use the machine learning capabilities. So we did sort of take this use case to the point where you're now able to see who the next propensity to default in the next month is. But if you extend that use case, you can now apply machine learning capabilities to see, okay, from these, who are the real ones that I should be looking at, that I can put support programs out for, who should I look at and say, well, it's best for me to walk away from this one. And those are the sort of things that you can do. This is one example. The other examples I can get into, and I'll sort of briefly mention, and this should give you an idea. If I'm in a casino and I'm capturing game data, or as everybody's playing, capturing everybody's data from the machines, and that's being stored in HDFS. And then taking that data, making a meaningful reduction as to what's the most valuable game, who's the highest player, who's the most loyal customer based on card swipes and how much time they're spending, bringing that over, mapping it into, let's say, CRM data on the customer side, and then putting out in real time while the person is still in the room somewhere in the casino, sending them loyalty bucks or tickets to a game or tickets to a show. All of this can be done by putting these technologies together. And can each one of us do it on our own? Sure, it's possible for each one of us to. Everything is possible. But the complementarity of this and putting them together, giving the push, giving the ease of use on both sides, the consumption from both sides, being able to use these together, that's how we look at Spark. We look at the momentum Spark has, the community Spark has, and it's clear we want to make sure that we can drive this forward as we build out the enterprise fabric for big data. So what's available now? We talked about the download. There's many more things to come after this, so stay tuned. But if you want learning resources, I talked about saphana.com. And then there's, for those of you who like the Khan Academy kind of training on HANA, you can get it at academy.saphana.com. Thank you very much, everyone.